Hello everyone. So I'm uploading this video after a long time. So I hope I can explain things to you clearly. So let's jump to the problem. The problem is maximum path scored in a grid. So what does the problem state? You are given an n cross n grid where each cell contains one of the values, either it's 0, 1 or 2. You're also given an integer k. You can start from the top left corner and you want to reach to the bottom right corner by moving only right or down, right? So they have given us that we will have two directions, right? One direction is either go right or you can go down, right? So these are the two directions which we can move. Each cell contributes a specific score and incurs an associated cost according to the given values. What does they say? They say that if the cell is a 0, then that will add 0 to your score and it will cost 0. Means 0 will cost 0 and add a score 0 as well, right? 1 adds 1 to your score and costs 1, right? So 1 adds 1 to score and its cost 1 only. And at the very end, 2 adds 2 to your cost and it will also be the cost value will be 1, right? So what return the maximum score achievable without exceeding the total cost of k. So these are the cost, right? These are the cost, and what they are trying to say is you should not exceed these values, right? So, and if there does not exist any path which will do so, you should return a -1, right? Great. So note, if you reach the last cell but the total cost exceeds k, the path is invalid, right? So that means, let's say this was your final path and the value at this point was k, and you reach this point with a value, let's say k plus 1, right? So this also becomes invalid, right? So invalid means you need to return a -1 over here, right? I hope the problem is clear in words. Let's look at a test case that will be more clear from that. So 0, 1, 2, 0, right? So the grid is something like this, right? 0, 1, 2, 0, right? And k value given is 1, right? So from this 0, what are the directions that are possible? Either you can go to this point or you can go to this point, right? Let's look up at this case where you first go down, right? So let's say you went down, right? And then now what is the cost that you will have? So you were standing at 0, right? You move to any new grid, right? So what we will do is, before explaining this, let's first look at the test case, then I will explain other things to you as well, right? So you can go to this 2, right? Your score will be 2, right? If you move to this 2 to index, right? And the cost that it will have is 1, right? Okay, after this you can go to the 0, score will be added is 0 and cost will also be 1, right? Added, the cost added will be 0, right? So ultimate score will be 2 and the cost to do this will be only 1, right? So if you look at this test case, the answer is 2, right? Similarly, if you look at this 0, 1, 1, 2, right? 0, 1 and 1, 2, right? And what they are trying to say is, let's say your k value was 1 over here, right? So k value, if it was 1, right? If you move to this grid or this grid, you might have a cost of 1, if I'm not wrong. And your score will also be 1, right? And after this path, if you follow, either you can go to this or this, and after this you will ultimately reach 2, right? Cost will be 1 plus 1, score will be 1 plus 2 from any path you follow, and you see the cost has exceeded the value of k, which will not be acceptable, so you need to return a -1 over. I hope that test cases were clear to you. And if you look at the time constraints, let's first look what are the time constraints. So mn are 200 and k is 10 to the power 3, right? So mn is 200, right? And k is 10 to the power 3, right? So from basic, if you think anything, right, you can't apply greedy over here. Why you can't apply greedy is the sole thing is you need to traverse in all directions, in two directions, right? And after traversing, you exactly don't know which cell which will have a value. Let's say you greedily came to 2 because you want to maximize your score. So you will always move to 2 instead of 1. Let's say this place had a 1, right? And this, let me write it clearly. You are standing at this point had a 1, and this point had a 2, right? So if you were greedy enough, you would go to this 2, and after this, let's say there were only zeros surrounded in all sides, right? So you got stuck over here, right? And let's think that this one had all twos in all the sides, right? For a second, just assume it, right? So if that happens, then this uh, at the long term would give you a better answer, right? So that's why greedy will fail here. I hope why greedy fails is clear to you, right? When you don't have a monotonic thing, right? You don't know that going to which path will give you a correct or the maximum answer. In that case, you should understand because you never know that which point is 2, which point is 1. After this one, how many twos comes. So in that case, you need to explore all paths. And whenever this thing comes to your mind, you should definitely think of DP, right? If you are exploring all the paths, you should be thinking of DP, right? So let's say you were standing at this point, right? And you had two directions to move, right? All the things which you should do is given over here, right? You should add 0 to your score, or add 1 to your score, or add 2 to your score, right? So if you look at this clearly, the thing which should come to your mind is what are the state that will be there in DP, right? See, first you can write a recursive solution, and then you can memorize it, right? But before writing that also, you need to understand what are the changing state, right? In a simple DP or a recursion form, you should know that what are the changing things, right? So at every point, you will have two things, right? One is I will be changing, and second thing is J, right? I and J will be continuously changing, right? Because you will be standing some at a one point you will be standing at this place, after some time you will be standing at this place. So I and J are two changing state, right? And the the third changing state can be used as K, but there is one catch over here. The catch is, let's say you used K as your third DP state, right? So ultimately your time complexity will be big of 200 into 200, right? At worst case, right? And into k is 10 k power 3, right? So ultimately it becomes 10 k power 2, 10 k power 4, and 10 k power 3, 7. So big of 4 into 10 k power 7, right? uh 2, 4, and 7, right? This might give you a TLE, right? So you can't use k as your DP state, right? So what can be the next condition, right? How can we solve without using this k, right? So let's think of this, right? Let's say you are at this index, there can be 200 maximum cells, right? M can be up till 200, right? And if you are exploring a path, can you guess what will be the maximum cost that you can have? Maximum cost which you can have, right? Let's think about it, right? Let's say you are standing at this and all integers were 2, right? Because 2 is the maximum value, and 2 and 1 both have the same cost as 1, right? So what will be the maximum cost that will be used to traverse in all these arrays, right? There are 200 cells, right? And you can do one thing, you can go from this cell, then this cell, and this cell. At worst, you will have to traverse on n plus m cells, right? Not more than that. You can, that is also a huge number. I'm giving you an upper bound that how many cells you will travel. See, if you are standing at this point, you can go either right or down, then you are at this point, right? After this you can go either right or down, so you won't explore these paths, right? So roughly, or I can say upper value won't exceed n plus m, right? So that gives you a brief hint that you should be using sum as your third variable, third DP state, right? So it becomes finally big of 200, right? And if all the values are n plus m, right, and all cost 1, so ultimately it will be u of n plus m, right? So it will be 200, 200, and at worst 400, right? that will be giving us a time complexity of big of 10 to the power 6, and that will be helpful for us, right? This will won't give us a TLE, right? Okay, so this thing might be clear, right? So what are the conditions now? How will we traverse? I will go through the code as well and make you understand what are we doing and why are we doing it. So if we are having two variables, right? First of all, let's go to the main function, right? So maximum path. First of all, if your answer is int minimum, right? If your answer is minus 199, right? In that case, you didn't find any valid path, and that should return a -1, right? So that's what I'm doing is, if answer is int min, so you should return a -1. Else return the answer whatever it came. And what is answer? Answer will be given by the solve function itself, right? So let's go to the solve function and look. We should look, right? So the solve function just looks like it's a huge function, but it's very simple. So we will have two variables. One is add score and one is add sum, right? So if grid of ij is 0, then add score will be 0. Score means what score you will get, and sum is what is the cost of it, right? Sum, or you can use cost as well. This will be more easy to understand, right? So instead of sum, we will be using add score, right? I think I have used sum everywhere. So let's continue with add sum only, right? So what I'm trying to say is add score will be 0 if you are on grid 0, value 0, and add sum will be 0. Similarly, if you are at 1, score added will be 1, and the cost added or the sum added will be 1. And if you are at 2, the score added will be 2 and sum added will be 1, right? So sum, the function, the variable which we are passing in our DP state or in our recursion. First, written the memoized, or sorry, recursive solution so that you can understand it well. And after doing this recursive solution, I think you will be able to understand how can we memorize in 2 steps, right? After recursion, memorization is simple, just 2 steps process. So I don't think that won't be difficult for you, right? So sum will be add sum, right? Whatever sum we got from the grade element, right? And if sum exceeds that value, right? If sum, let's say you were on this grade and you had a sum of 2, and let's say k was 3, right? And you move to 1, right? And the sum was 3 and you move to 1 and your sum exceeded, right? If your sum is greater than k, then will this path in future be valid? No, because after this reaching this sum, you won't be able to reduce it, right? So if sum is greater than k, simply return int minimum, right? And if you have reached the last point, right? If you have reached I equal to n minus 1 and m equal to n minus 1, both the elements are I equal to n minus 1 and j equal to m minus 1, sorry. So in that case, you should return the add score. The whatever the score has been added, you should return it, right? Okay, the first thing is we will create a right and down. These are the two variables or the two valid steps that we are going to have, right? So if I plus 1 is less than j and j plus 1 is less than n, what I'm trying to do is I'm checking that is these two things valid. See, this was the solution which I have written in the contest. So don't think why these solutions are so vague. What my thought process was at that very moment, that's what I'm explaining to you right now, right? So if you are at this position and I plus 1 is less than n, right, and j plus 1 is also less than m, means both right and down are valid, right? So for right, you will call the solve function, right? And for the down, you will call the solve function again with I plus 1 in the right and j plus 1 in the down, right? And if I plus 1 is less than n, right, only I plus 1 is valid. So you should go only to the right direction, right? So you will go in the right direction only, and this will be a valid path, right? Okay. And if j plus 1 is less than f, you should go only in right down direction, and that will give you a value, right? And if right is equal to int min and down is equal to int min, simply return int min. And if any value, right, in future gives you a 1 minus 1 right, in that case, you won't have this path as valid. So simply return a minimum, right? So if both of them gives minimum, give return minimum. If right is equal to int min, then only the down path is valid, right? So let's say right path, right? When you are traversing or traveling to the right path, this path gives you a -1 E9. In that case, what you should do, you should just use the down function as your solution, right? If down is also equal to int min, then you should use the right function. Else, you should return add score. So whatever score you got till this point, you should return it, right? And add score plus maximum of right and down, because we want to maximize the score, right? So that's it. That is the recursive solution for this code. And if you want to add the DP state, right? DP state will be what? Let me write it over here. I will give the DP code. For explaining, I have written only the uh, recursive solution, right? So DP will be DP of I, J, and sum, right? So whenever you are solving any DP problem now, you should be very careful of what are the changing variables in your function, right? I is changing, J is changing, and sum is changing, right? Doing this will reduce your time complexity and this will be accepted, right? So I hope the problem statement was clear. The time complexity was explained also, right? And I don't think any doubt won't would be there in this problem. If there is, you can ask it, and I can memorize it in 2 steps. I hope you know this, right? That if what are the steps for memorization? If dp of ij comma sum is not equal to -1, then return it, right? Is not equal to -1, return that, right? And at the very end, wherever you are returning, just add i, dp of ij and sum, right? Equal to this. Right? So these are the things I have explained the code as well. I will give you the DP memorized code for it. And I have explained the time complexity as well.